Hey there, this is Math 7, Unit 4, Lesson 5. It's called Say It With Decimals, and today we're going to be using decimals to describe increases and decreases. Alright, so you began today's lesson with another notice and wonder from fractions to decimals, and so it says that a calculator gives the following decimal expansions for some unit fractions. And so what you were looking at in class today perhaps was looking at when you took a look at these fractions 1/2 all the way up to 1/11th. If you use a calculator, what would actually come up on your screen? And so as you kind of maybe punch those into a calculator, or you just took the book's word for what those were, you maybe took a notice of like, well, if I did a 1 divided by a 2, I got a simple fraction that just stopped at 0.5. It didn't repeat, it didn't go on, it just stopped right there. Other times, when you do a 1 divided by 3, we get a decimal that seems to just go on forever and ever and ever until you run out of room on our calculator. And so there's a variety of things that happen when you do divide or work the fraction out as a division problem with a calculator and expand that out. So that was kind of what we saw at the beginning of the lesson there. And so today what we're going to take a look at is we're going to take a look at first working with some repeating decimals. And so just as a kind of quick review as we do this, before we jump into these problems here, if you had something like 7/8, just recall that 7/8 is the same as, or saying the same idea as 7 divided by 8. Okay, 7 divided by 8, something like that. Now I can take this fraction then and put it into a long division format. All right. What I used to do with my kiddos is I used to also coach wrestling sometimes, and so the wrestling, we would say that the guy on top got the win in the wrestling match often, so that means he got to own the nice new house and live inside the house. Alright, lucky guy, he won the wrestling match, gets to live inside the house. This guy lost the match and has to sleep outside tonight. So that's how I would usually set mine up with my students in my class before. So we have 7 divided by 8, and I often would just put a decimal there, and I would tend to put 3. I don't know why, I always just drew 3. And if I ever put a decimal, I'd immediately put that decimal place up there. I like to call it my satellite dish, just sticking right above there. And I'd say 8. How many 8s are going to go into 7? We would say 0. So then 8 into 70, that becomes more like 8. 8 times 8 is 64. And so now we're going to subtract there. And we have to borrow, and so 10 minus 4 is 6, that becomes 6. We bring the 0 down. 8 goes into 60, we would say 7 times for 56. Subtract once again and we get 4. Bring that 0 down and we have 40. And 8 goes into 45 times, and that goes in there evenly with nothing left over, so we can stop. So 7 divided by 8, or 7/8, can also be written as a decimal as 0.875. We're going to follow that same pattern here and use long division to express each fraction of the decimal here in 5.2. So again, in the setup, right, 9 is our winning wrestler. He's going to win the match, and so we're going to put him inside the house. 25 lost, we're going to put him outside. Because it's a smaller number than that one, I'm going to go ahead and add my decimal and add 3 zeros. I'm going to immediately put my satellite dish on the top of my house so I can enjoy my television that I won inside my new house. 25, does it go into 9? It does not. How about into a 90? Sure. Think about quarters, 25, 50, 75. That goes in there 3 times. If I did one more, I'd be at 100. That's too big. So we're going to use 3. 3 times 25 is 75. And we're going to subtract. 10 minus 5 is 5. 8 minus 7 is 1. So now we have 15. 25 won't go into 15, so I bring this 0 down here. And 25 goes into 150, in our case here. 25, 50, 75, 100, 125, 150, we would say 6 times. And it goes in there evenly, so we're all done right there. When I do 11 30ths, same idea. 11 won the match, it's going to go live inside the house. 30 lost, gets to live outside. I have my television, need to connect my satellite dish there, and add a couple zeros so I can enjoy the show. 30 does not go into 1, it does not go into 11, does it go into 110? It sure does. We would say 3 times. 3 times 30 is 90, and we subtract there, so 110 minus 90 is going to be 20. Bring down a 0. All right, and so we have 200. The way I think about this, is I go, well, 3 as itself goes into 21 almost 7 times, because 3 times 7 is 21. So I'm going to go ahead and go with 1 less than 7, which is 6. So 6 times 30 is 180. And when I subtract, again, get 20. And so I can see that I'm going to have a repeating thing here, because that becomes another 6, and it's going to go on and on and on. So this solution becomes 0.36, and I put a repeating bar over the 6 there. For this one, again, 4 wins and goes in the house, gets on top. Decimal point, 000, and satellite dish on top. And I have an 11 on the outside. And 11 goes into 4 0 times. 11 goes into 43 times. So 3 times 11 is 33. And so we subtract, and we end up with 7 and a 0. 11 goes into 70 about 6 times for 66. And we subtract, and here we have a 4. So I don't have another 70, I have 40. So that goes in there 3 times. And notice here that I'm now back to, with a 40, back to where I started, back to where I began again. If I do this one more time, I end up with 33 and 70, I end up with a 36 and 66, and I'm back to 40 again. So my repeating part becomes this 0.36. So my solutions are 0.36, 0.36 repeating, and then 0.36, and I repeat that whole part there. So what is similar about the answers and to the previous question here, and what's different, is that I can see that I have the same digit in each of those place values there, but in the first case the value is stopping after I get to the hundredths place there. This one, the hundredths value tends to repeat, and here this one, both values are going to repeat again and again. If I use the decimal representations to decide which of these fractions is the greatest value, here's what I come up with. I can think of it like this. This is 0.36, my first one, and I can just add a placeholder 0 there just for now, okay? This is my tenths, my hundredths, and my thousandths place, all right? For the other next one, I have 0.3, and it's the 6 that repeats, so I'm going to add another 6 in the thousandths place. And then for the final one, I have 0.36, and then I have, again, it repeats with a 3 and a 6 there. Right? This one's not quite as critical for what I'm doing right now, because to decide which one's the greatest, I look at the largest value in the thousandths place, which in this case would be that one there, which is the 0.3, and then the 6 repeating right there. That's going to be the greatest value because that has the largest value in the thousandths place. Okay? So one common, next section. Are you ready for more? One common approximation for pi is 22 over 7. Again, it's an approximation. Express this fraction as a decimal. All right, so that means go ahead and kind of work that out. So 22 is the winner of the match, goes inside. 7 goes outside. 22, I'm going to put up decimal and 0, 0, 0. 7 goes into 22 3 times for 21. We subtract and we have 1 and a 0, bring it down. And so 7 goes into satellite dish on top. 7 goes into 10 one time, so we have 7 there. Subtract, we have 30. Bring that down, right? 7 goes into 34 times, so we have 28. Subtract, we have 2. Bring a 0 down, we're at 20. 7 goes into 20 a whole 2 times, so we're at 14. Right? We subtract, bring another 0 down. Boy, this keeps going on and on and on, doesn't it? Right? And it will. It'll go on for a long time. 8 times 7 is 56, and then we subtract and we have a 4. Right? And so this is going to go on for quite a long period of time here. But the longer I go, the more closer I get to an approximation of pi in one sense. So I get a closer approximation the further out I go. So 3.1428 is probably a closer approximation to pi than just plain 3.14. It just gets a little more detailed the further out I go in my problem there. Okay, so it's a closer approximation is how we would look at that. Let's take a look at how this is going to tie in with today's lesson. All right, because we're looking at some tape diagrams still. And so it says match each diagram with a description and an equation. When I looked at these questions the first time, I thought, well, there's a lot of things I can look at. I have an increase by a quarter, a third, increase by 2/3, decrease, decrease. You do need to decide what you want to look at in terms of what are you beginning with and then what are you ending with. So for me, I'm going to start with the x value, okay? Meaning, I want to say this is my initial part. My original component is going to be the x. That's what I'm starting with. And then the change, whatever that might be, the increase or decrease, is going to be the y. All right, that's just how I decided to do these problems here. Could you do it the other way? You could. You could say you're starting with y, and how do you get to the x? You can do that for sure. I'm going to go ahead for these examples here and start with the x as being the original, and then say what happens to go to the y value there. So when I look first of all at this x value a, I can see that the whole here is in 4 sections, right? I have 4 parts there. The y though is less. This less, because it's not having that part there, I recognize this is going to be a decrease, right? This is a decrease. To go from x to y, I am decreasing in the number of sections that I have here. So I know it's a decrease. So I'm looking now at either this one or this one. The question then becomes is how much am I decreasing it by? Am I decreasing it by 1/5 or 1/4? Well, we have a section, a block here that's divided into 4s. I have 1, 2, 3, 4. I have fourths here, and I can see that what I'm eliminating is I'm eliminating one of those 4 pieces to get the y value. So in this case here, we would say that this is a decrease of 1/4 because we are going from a large piece to a smaller section, and the reduction what we're taking away is this 1/4 piece there. So this right here, A, goes with a decrease by 1/4. All right, now let's take a look at B. With B, we can see that our original value is here, the shaded component, and now we seem to be adding something to what we had originally with x in order to make y. So this is going to be an increase, isn't it? Because it's getting larger than the original. The original is the x, and our y is our new one, and that is an increase. The question though again is increasing by what? Well, to find out what it's increasing by, you still need to go back to your original. My original has it broken into 4s. 1, 2, 3, 4. Notice this shape here, or this piece, is the same size as each of these, isn't it? So I am increasing by one of these pieces. I'm just taking a piece and I'm putting over here, just not shading it in, but it's the same size, the same value, so to speak, as what's right here. So what am I increasing by? I'm increasing by one of these chunks, and one of those chunks is simply 1/4. So I'm doing an increase of 1/4, which is right here for B. Now, to talk about an equation, all right, equations are going to be a little bit different now. We have to talk about the equation. Well, what is happening from one to the other is what we're talking about. So the equations here are set up as y equals a constant of proportionality times x, and we can see we have 1.6 repeating, 1.3 repeating, 0.75, 1.25, 0.4. We have a variety of things there. Okay, so something is changing to make that happen. So let's go back then to talk about this first one here, A, and bring it back to our previous lesson. If this is a decrease of 1/4, what we're saying is that initially I had a whole x, I had one x, and then for the y value, so y is equal to, I have a whole x, and I'm going to subtract it, decrease 1/4 of an x, right? So I'm going to decrease by 1/4 of an x. That's kind of my setup here, is I have initially my original 1 times x, so the whole x, and I'm going to subtract from that whole x 1/4 of x. So using that distributive property again, let's move this over here, we end up with 1 minus 1/4, right? That's this part and this part times x. Well, what is 1 minus 1/4? 1 minus 1/4 is actually 3/4, and then x is simply x. So what I have really, if I think about it, to do a decrease of 1/4 is I have 3/4 x is what I'm going to have. Y is going to equal 3/4 x. But when I look over here, I notice I don't have any fraction answers, do I? They're all decimals, because that's part of today's lesson. So I need to take that 3/4 and let's turn that into a decimal form. So 3 is on top, 4 goes outside the house. Put my satellite dish on top, some space holder zeros. 4 goes into 3 0 times, and 4 goes into 30 7 times for 28. We subtract and bring down a 0. 4 goes into 25 times, and we're all done. So as an equation then, I could change this equation over to say actually it is y equals 0.75x. Okay, so this is my answer for A. Okay, for my decrease. So these two go together like that. Let's take a look at this one here. For this one, again, same idea. Let's take our initial, which is our original value x. It's 1 times x, right? So y is going to equal 1 times x, and it's an increase. So we're going to add to that how much? We're going to add to it 1/4 of x. Okay, so we started with our original 1 times an x, so the whole thing, plus 1/4 of the whole thing. Now I can do my distributive property, and I have 1 plus 1/4 times an x. Okay, just grouping those things together. Here's my 1 plus a 4th, and I put my x's together there. 1 plus 1/4 is 1 and 1/4. That's one way of writing it. It's also 4 times 1 is 4 plus 1 is 5/4. So it's also 5/4 x, depending on how you want to write that. I could write 1 and 1/4, or we could write 5/4 x. So y equals 5/4 x. Again, that's not one of our choices, so I need to use the division part here. That's what we were talking about. So here's my 5, here's my 4, 5, and I put my zeros there. 5 goes into 4, 4 goes into 5 one time there, and I have to subtract. It goes into 10 a whole 2 times for 8, and we subtract, and it goes into 25 times. So I end up with 1.25. Sorry, I ran out of space there, right? So I can rewrite this as y equals 1.25x. Again, if you were using a calculator, it's a little bit faster there, right? I could just do 5 divided by 4, and I get 1.25. So my equation for B is y equals 1.25x, which is down here, right there. All right, so that's the idea for what we're doing, okay? Just combining a previous lesson with today's stuff and then converting fractions into decimals. So it says draw a diagram for one of the unmatched equations. Okay, so let's do that. I'm going to do this one right here. I'm going to do the increase by 1/3, just to do one more and show you how this one works. Okay, so if I did an increase by 1/3, I'm going to go ahead and draw my original in thirds, meaning this. I'm going to draw my original x like this, and I'm going to put it into thirds. That's my original x value. Okay, that's my x value there. It's in thirds, thirds, thirds. Now if I'm increasing by 1/3, that means I'm going to add another piece, the same dimension, the same size as what I've already used. That piece right there, that's my 1/3 increase, and now the whole thing is going to become my y value. So my original was the shaded part, that's my whole, and I'm increasing by 1/3 to get there, right? That's an increase of 1/3. So if I write that as an equation, I have 1 times x plus 1/3 of x. I rewrite that as 1 and 1/3 x by combining those together. And I can rewrite that as 3 times 1 plus 1 is 4/3 x. And then I could write that as a decimal by saying 4 divided by 3 is 1.3 repeating x. And so y equals that part right there. So that's one other one you could have done. You could do the other ones and see what you get. I'm going to move on. Your next activity is an in-class activity, just doing some card sort, and your teacher gives you a set of cards that have proportional relationships represented 2 different ways as descriptions and equations. So your job is to match the description with an equation. So your teacher will give you those cards for you to practice that. Good activity for you to do. And I'm going to summarize this up and move on to the homework. So today's lesson here, long division. gives us a way of finding decimal expressions for fractions. So just something we just need to know. Sometimes we're going to have a fraction, 9/8, and if we have that fraction 9/8, we can divide it, and by dividing it, we end up with a decimal equivalent of that fraction right there. The key thing here, it is important to be able to work with both. Your problems today and ongoing are sometimes going to use fractions, and sometimes they're going to use decimals. And sometimes one is easier than the other. If you know how to work with both, you can figure that out. All right, let's take a look at your homework here before we wrap up today's activity. All right, so here we go. Saying it with decimals. Match each diagram with a description and an equation. Okay, so here we go. I'm going to just look at the picture first before I even mess with any of this stuff here. This here begins by saying, all right, I have the whole, which is my x, 1 times x. And I see that I am decreasing here, so that means I'm going to be subtracting. And what I'm subtracting is I'm subtracting 2 of those boxes out of how many? How many parts do I have in my original? 1, 2, 3, 4, 5. So 2/5 times x. All right. Now we can use some distributive property things here, and we can say this is really 1 minus 2/5 times the x, and 1 minus 2/5 becomes 3/5 and an x there. So what we're doing is we're now going to have to turn it into an equation as well. So these are decimals here, so I do 3 divided by 5. 3 divided by 5 is 0.6, so I actually have 0.6 or 0.6x. All right, so what is all that going to be? Well, let's back it up here a little bit for my options. Am I increasing or decreasing? I'm removing something, so we would say I'm decreasing. So these are my 2 options. What am I decreasing by? We said we were decreasing by 2/5. So that's going to be our choice for A, decreasing by 2/5. Now in terms of an equation, we went ahead and worked that out. And so we said that y equals 0.6x, which happens right there for choice A. All right, so that's our A one. Let's do the same thing with B. B, we look at our initial or original amount, which is our x. We're starting with the x again. So x is there. In this case here, are we increasing or decreasing by going to y? Well, we would say we are increasing because it's getting larger. So we're going to be adding something to y. How many are we adding to y? 1, 2, 3, 4, 5. That's our top value. And our bottom value goes back to the x. What was our original thing broken up into? How many chunks? 1, 2, 3, 4, 5, 6. So we're adding 5 out of 6 to our new one, and we're multiplying that by x, right? So this is going to be an increase of 5 out of 6. So we can come back over here to our descriptions and say this is going to be B, an increase by 5/6. Now for the equation part, we can combine things. 1 plus 5/6 is 1 5/6 times x. I can turn that into an improper real quick. 6 times 1 is 6, plus 5 is 11, so I have 11/6x, and just for sake of time, 11 divided by 6 is going to be 1.8, and the 3 seems to repeat there, so 1.83 repeating x. I put a y equals out in front, and that becomes my equation, which matches this one here for B. Draw a diagram for one of the unmatched sections. All right. I'm going to do the increase by 2/3, just because it's there. So an increase by 2/3, what I would do is I'm going to draw my shape, and I look and see how many sections do I want. I want a little picture, a little tape diagram that has thirds. So there's 2/3. My original is in thirds. This is my x value. And I'm increasing by 2/3 for y. So I'm going to add 1, 2 more, and that becomes my y value, right? Because I'm increasing by 2/3. And that's what I'm doing. If I wanted to write an equation, which would be a good thing to practice doing, again, I take my original, 1 times x, I'm adding to it 2/3 of x, And then I can combine 1 and 2/3 is 1 and 2/3 x. 3 times 1 plus 2 is 5/3 x. And if I did that as a decimal, I would call that 1.6x. And we could set that equal to y equals 1.6x. And that 6 repeats, by the way, when you use a calculator. All right, moving on. Number 2. At the beginning of the month, there were 80 ounces of peanut butter in the pantry. All right. Since then, the family ate 0.3 of the peanut butter. How many ounces of peanut butter are in the pantry now? So they're eating something, so the peanut butter is going away, isn't it? This is going to be a decrease type of problem, a decreasing kind of problem. We start with 80, and now we have less. So think of it like this. I had something, I have peanut butter, and I'm decreasing by, in this case here, 0.30x. Okay, my original peanut butter, and then what I have now. So all together is going to be what I have now. Now in this case here, they told us what our x value is going to be. We're starting with 80. So I do 1 times 80 minus 0.30 times 80. And we'll do our same process here. Let's group things together. So 1, what is 1 minus the 0.30? 1 minus 0.3 times 80. This is our problem. 1 minus 0.3 is 0.7. So 0.7 times 80 is what I'm being asked to figure out. Okay? So it's good to set this up the way we've been doing it. The whole thing minus the 0.3 of the peanut butter. And that's our decrease. Now looking at our solutions here, we have A, 0.7 times 80, and that's what we have right there, no problem. This one, 0.3 times 80, is a distractor for if you just use that value. That would not be correct, would it? Here we have 80 minus the 0.3. That's not going to work. And this one would be if it's an increase. So that's not going to work either. So A is our best answer choice right there. All right, let's turn the page and look at number 3. On a hot day, a football team drank an entire 50-gallon cooler of water. Way to go. And half as much again. Half as much again. How much water did they drink? All right. So they drank 50 gallons, the whole thing, and half as much again. So they drank a whole thing and half of a whole thing. That's the idea. So 1 and a half, we combine those together to do 1 and a half. That's our first one. And 50 and 50. Okay, we're going to group those things together. So 1 and a half is 2 times 1 plus 1 is 3 over 2. So 3 over 2 times 50. This is an example where I could turn it into a decimal if I wanted to, or I could leave it as a fraction. It's up to you what makes sense to you. I'm going to leave it as a fraction this time because I can do 2 goes into 50 25 times, and 3 times 25 is 75. So we'd say 75 gallons of water is what they drank on that day. For B, we have Jada has 12 library books checked out. Han has 1/3 less than that. Okay, so again, the setup. 1 times 12 for Jada, and because it's less, minus 1/3 of that same 12. That's our setup. So let's combine our things to distribute. Put those together. 1 minus 1/3 times our 12. The 12's in both of them. 1 minus 1/3 is 2/3. And it's still times 12. And again, if I wanted to turn that into a decimal, I could. I ended up with 0.666. It goes on forever and ever. I don't know if I want to mess with a 0.6 repeating with a 12 when I could just do 3 goes into 12 4 times. So 1 on the denominator, and 2 times 4 is 8. We would say 8 books there. All right, number 4. All right, number 4. If x represents a positive number, select all the expressions whose value is greater than x. Greater than x. To be greater than x, it's also going to need to be greater than 1. Okay, that's just what we have to keep in mind. If I have a value less than 1, it's going to become less than x. So we want numbers greater than 1. So if I look at my combinations, 1 minus a fourth becomes 3/4. That is less than 1, won't work. 1 plus 1/4 is 1 and 1/4. That's greater than 1. That's going to work. 7/8 is less than the 1, so it won't work. And 9 out of 8 is the same as 1 and 1/8. It's greater than 1. That would work. All right, and number 5, our last one I think for the day. It says a person's resting heart rate is typically between 60 and 100 beats per minute. Noah looks at his watch and counts 8 heartbeats in 60 seconds. Is his heart rate typical or not? All right, let's take a look. If normally you have 60 beats in a minute, okay, we're doing things by minutes, we can have anywhere from 60 beats in 1 minute, right? 60 beats in 1 minute, all the way to 100 beats in 1 minute. That's the normal kind of range of heartbeats we're dealing with. So for Noah, he has 8 heartbeats in 10 seconds. Notice it's seconds, not minutes. If I want to put this in terms of minutes, I need to multiply by 6, because in 10 seconds times 6 would give me 60 seconds, and that gets me to a minute. So I'm going to multiply by 6. 8 times 6, whatever to the bottom to the top, because it's like a giant 1, as my teachers call it there, right? All right, so 8 times 6 is 48, and 10 times 6 is 60. Now I can just go ahead and say this is going to be, this is seconds still, right? Seconds, and this is beats. I'm going to rewrite this as 48 beats in 1 minute. All right, because I know 60 seconds is the same as a minute. So for Noah, he has 48 beats in 1 minute. Is that typical? Well, 48, looking at 48, where does 48 fit in this range? Is 48 between 60 and 100? Nope, it's less, it's over here. So we would say that for Noah, his heart rate is a little bit too slow. It's not typical for what should be happening there. Now, B says to write an equation for H, the number of times the heart beats, in M minutes. The best thing to do here, I would recommend, is making yourself a little chart. Okay, so let's do our minutes, and let's do our beats. Now our beats, we're using the H value for beats. And so for Noah, in 1 minute, it beat 48 times. Now once you have this set up, can you find your constant proportionality? Sure you can. 48 over 1, that y over x is just simply 48. So in terms of how we set this up, here's my x, here's my y. I'm going to say h, the y value, equals my constant proportionality, 48 times x. And my x is actually minutes, so let me erase my x and turn it back into minutes. Okay? And that's how you set that up. Sometimes it's helpful to make that table, and there you go. That's it for today's lesson. Have a great day, and we'll see you next time.